Welcome back to another episode of Dave Does Math from Home. This is part 3 of our video series on function transformations, section 2.5. We've already talked about shifts, up, down, left, right. We've talked about stretches, making things taller, shorter, wider, thinner. Only thing left to talk about is flips. So let's talk about flips. I want to talk about f of x equals negative x squared. Seems like a good place to start. This transformation is happening on the outside. So I've got my x squared, then I'm going to make it negative, which means that when I make a table of values for this, the base function happens first, and then the transformation happens. So these numbers are going to be my standard set. Negative 2, negative 1, 0, 1, and 2. And I'll get the standard spread of outputs 4, 1, 0, 1, and 4. So all I need to do in this transformation is make them all negative. Negative 4, negative 1, negative 0, negative 1, and negative 4. So for this, 1, 2, 1, 2. For this particular transformation, again, I'm going to start with the base function. This is the base. Our very standard issue, regular old-fashioned parabola, goes up. The transformed function is going to be down here at negative 4, negative 1, 0, negative 1, and negative 4. Transformed function is doing this. So this negative on the outside flips us upside down. So flip upside down is my words for what's happening here. The book calls this a vertical reflection. Hopefully we can also imagine pretty easily what happens if we do g of x equals negative square root x. Your standard square root function is over here. Y equals square root x. Negative square root x would be down here. So this is the vertical reflection. Just take something, flips it over the y-axis. Next up, we need to talk about horizontal reflections. We're going to flip things from left to right. Flipping things from left to right is not going to work very well with the parabola because when you take the parabola and you flip it left to right, nothing appears to change. So we're going to work with the square root function on this one. We're going to look at the square root of negative x. We're going to make our 3-column table. We're going to have x, negative x, and then the square root of that. So as usual, when the transformation is on the inside, the base function is what happens between columns 2 and 3, which means I'm going to start with this. I want these numbers to be 0, 1, 4, and 9, so that their square roots are the nice easy 0, 1, 2, 3. If I want negative x to be 0, that means that x is 0. If I want negative x to be 1, that means that x needed to have started as negative 1. If I want negative x to be 4, that means I had to start with negative 4. And if I want negative x to be 9, that means I needed to have started with negative 9. Okay, so the base function here, 0, 0, 1, 1, 4293. Base function here, same as it ever was, y equals square root x. The transformed function still has my 0, 0 point. It has a negative 1, 1 point, a negative 4, 2 point, and a negative 9, 3 point. This is how you get functions to flip left to right. You put the negative sign on the inside of the function. So again, my words for this are flip left to right. The book's word for this is horizontal reflection. Of course, you can use whatever words you like. Use the words that make the most sense to you. I like saying the word flip, so I use the word flip. I don't like the word reflection. It just seems unnecessarily complex for something that is essentially just a flip. So this is flips. And this is the last of it. We've done vertical shifts up and down. That's adding and subtracting on the outside. We've done horizontal shifts left and right. That's adding and subtracting on the inside. We've done vertical stretches and squishes. That's multiplying on the outside. We've done horizontal stretches and squishes. That's multiplying on the inside. And now we've done flips. That's putting a negative number on the outside for a vertical flip, on the inside for a horizontal flip. And that's it. So the last thing I want to do for this section is I want to create a big table of all of this information so that it's easily accessible. Take away the top of this so I have lots of room. The two places these operations can happen are the outside and the inside. And the things that we're going to do are we're going to add, we're going to subtract, instead of saying multiply and divide, I'm going to say multiply by a number greater than 1. And I'm going to multiply by a number less than 1. So when I was going through these examples, I never did like an x over 2, because I feel like adding division into this just sort of muddles it up. So instead of doing x over 2, I did 1/2 times x. So I like to think of these all in terms of multiplication. So multiplication by numbers like 3 or 4 that are bigger than 1, and multiplication by numbers like 1/2 or 1/3 that are less than 1. This is what I do instead of multiplication and division. What a terrible B. And then we have multiply by -1 is our last of these. So we're going to figure out what happens in each of these situations. When we add on the outside, this is a shift up. When we add, or when we subtract on the outside, this is a shift down. These are the two really intuitive ones. When we add on the inside, that's when we're going left and right, and that's the one that's sort of backwards. So this is going to shift left, and when we subtract on the inside, this is going to shift right. So this is our shifts category. All of the addition and subtraction, it's all shifts. Outside is vertical, inside is horizontal. That's all of that. When we multiply by a number bigger than 1 on the outside, this is a stretch taller. When we multiply by a number less than 1 on the outside, like 1/2, this is a squish shorter. And again, these are the two that pretty much make sense when you do it on the outside. When you do it on the inside, it creates, sort of does this like backwards thing. So multiplying by a number bigger than 1 on the inside, this is like when we multiplied that 3 on the inside of the parabola. This got it squished thinner. When we multiplied by a number less than 1 on the inside, this stretched it wider. So these are our stretches and squishes. Not squisher, squishes. These are the stretches and squishes, and that's all of your multiplying by numbers. You multiply by a number that stretches and squishes. On the outside, you're going to make it taller or shorter, because that's outside is the vertical column. On the inside, you're going to make it thinner or wider, sort of backwards from how you would expect. So multiplying by -1 on the outside is a flip upside down. Multiplying by -1 on the inside is a flip left to right. So these are all your flips. Multiplying by -1 flips things. I'm going to try to use the same symbol. And again, outside vertical, inside horizontal. All of these things are vertical. And I use the word intuitive here. What I mean by intuitive is that it goes in the direction you'd expect. Adding is up, subtracting is down, multiplying is taller, dividing is shorter, and then the flip is just the flip. All of these things are horizontal, and they are counterintuitive. By which I mean it goes in the opposite direction of what you'd expect. Adding goes left in the negative direction, subtracting goes right in the positive direction, multiplying makes it thinner, dividing makes it wider, and then the flip is just the flip. So this is the full and unabridged table of all of the transformations that we will encounter. And I would encourage you to put this in your notes, because if you're taking pre-calculus, you're going to see this again a lot. We do a lot of this in pre-calculus. We did it here with a parabola and a square root. We're going to do this a lot in pre-calc with exponential functions, logarithmic functions, and a lot of trig functions. When we do it with trig functions, they all get different names, which is bizarre, but that's fine. Like when we do this, when you shift a trig function up, you don't call it a shift. You say that that's the midline. They get fancy names when you do it to trig functions, but it's all the same idea. It's all the same material. Yeah, so that is everything. And that's it for me.